Welcome everyone. My name is Régis Glorieux from Telerex Belgium, and I will introduce our guest speaker of today. Most of you probably know Telerex already, and then you are probably aware that Telerex is very strong in the market of power supplies and DC-DC converters. We are working with Traco for many years now, and Alexander, the speaker of today, has lots of experience in this market. He's a sales manager at Traco, and he will give you an overview of the ruggedized solutions Traco can offer for heavy industrial applications and the railway solutions they have with concrete reference to both markets. Before I pass you to Alexander, I would like to inform you that at the end of this webinar, which will take about 45 minutes, there will be a poll. It would be nice if you could complete the poll immediately. Thank you, and I pass you to Alexander now.
Sorry. Thank you, Hanneke. I was just informed that my microphone was still mute. So thank you for this. Thank you, Régis, for the introduction. As mentioned, my name is Alexander Laube. I'm area sales manager at Traco Power. And I'm responsible for the Western European region, which obviously is including the Benelux region. From my personal history, I'm now since a little bit more than 1.5 years with Traco Power, but I'm pretty experienced in the electronics and the electronics distribution world, and have more than 13 years with a complete focus on power supplies experience. And that's why I'm really happy to work with today with the great partner company of Telerex. And thank you very much to the entire Telerex team to give the possibility to do this presentation here today. So what's the plan? What do we want to talk about? So after a very short introduction of Traco Power itself, I will, so who we are, where we come from, in case you don't know Traco too well. We will then start diving into the main topic, into the ruggedized power products, and we will have a big relation to the railway portfolio, because this is a good overview of the requirements that we have to cover. We will talk about the requirements a little bit more in detail. We will have a look on related norms, and we will take a look of how Traco Power is tackling these challenges. Before we then go into the portfolio overview, to give you an overview of what is available, what is coming soon, and so on. And then we step into the questions and answers session that Régis had already mentioned during his starting speech. All right, let's start with the presentation, or with the introduction of Traco Power itself. So as you maybe hear from my accent, I'm German, but I'm located in my home office somewhere countryside between Frankfurt and Cologne. But in normal times, I'm part-time Swiss. So I work for our headquarters in Switzerland, and you might see this is not a live picture. If you replace all the green with white, then you can imagine how it looks today. So it's a very nice place in central Switzerland, also pretty countryside, in a bigger village which is called Bar, somewhere in the middle between Zurich and Lucerne. And this is our global headquarters, and is including everything the global headquarters needs. So we see sales management, product management, marketing, technical service, and also a logistical center. So on the left side here, you can see our warehouse, and we are holding here a pretty big portion of uncommitted stock. In average, that's $25 million worth of goods that we are having here in our warehouse to be available for you, and have quick availability for smaller quantities if it comes to samples or so on. The company is already pretty old. We are more than 40 years on the market, and we are still in family hands, so it's completely privately owned. And the progress of handing over into the 4th generation of family ownership and family ownership management is just right now ongoing. We have roughly 140 employees here, and but we are, as a small company, we are still calling us a global player. So we have several locations globally. Beside our headquarters in Switzerland, we have a design and engineering and research center in Ireland on 2 locations. One in Wexford, which was probably the people don't really know, and one in Cork, which is a little bit more known. And from here, we are developing a big portion of our AC to DC product range for the, let's say, off-the-shelf product or product range. But we are also doing customizations, modified standard products, or full custom solutions for our customers if needed. Besides this, we have sales organizations in Germany, in France, and in North America. And in all other countries, we have the international sales team, where I'm part of, and are working with long-term specialized distributors like our friends from Telerex here, and have to present through our distribution channels. Production is happening in Asia, which is these days for electronic equipments a good standard. Our focus markets, I mean, the name is saying it, Traco Power. We are talking about power supply solutions. How do we define the power for our company? You can see on this slide. So we are offering DC-DC converter solutions starting from 1 watt and a little bit below, up to 300 watts. We have industrial AC-DC power supplies starting from 2 watts up to a kilowatt. We are offering a wide range of DIN rail power solutions in AC-DC and in DC-DC, starting from 6 watts up to a kilowatt. And the customized solutions that I have mentioned earlier, we have done projects up to 40 kilowatts. So the range is pretty wide, and I think we will find something for you here. With regards to the design life and product reliability, we have created this nice bubble chart here to show where we are feeling very well. So the Traco Power portfolio is the red bubble there in the middle. And you can see that we are not too much into toys and consumer electronics, because our product reliability is on a little bit higher point than this market is asking for. So our sweet spot is everything that is related to industry, test, measurement, and automation, energy systems. We are covering a nice portion of home building automation electronics. We are very good in medical and healthcare. And we have a very, very nice portfolio in the transportation and railway area. And this finally is our topic of today. So let's go forward to the next slide. Railway requirements. I mentioned I take railway as a reference because it's showing a very good example for this harsh environment things. So why is this market of railway so interesting for us? And you can explain this easily if we look on the global trends that are happening these days. So we have a massive increasing of traffic, not only in transportation, but also in people's transportation. I mean, these days are not the reference, as everybody has to stay at home, but in normal times, traffic is increasing a lot. And this means that also the railway infrastructure needs a lot of investments. There are many programs also from the governments ongoing to create new infrastructure, but also to refurbish and modernize the existing infrastructure. And all these programs have one thing that comes along with that, and that means that the electronics demand and the electronics part of these modernization programs becomes more and more important. So talking not only about the, let's say, the driver's seat and everything around it of a train with telemetry systems and steering and so on. It also comes with safety questions. We are talking about braking systems and the GPS systems on the trains. But we also talk about the electronics in the passenger area, so infotainment systems. All these things are expanding. And then if we make the brackets a little bit wider, also the direct surrounding, not only the rolling stock is interesting, these harsh environment products. If we go to the, for example, the track bed that you see on the picture here, and everything which is around there, so the track switches or signaling systems, they are also part of the railway electronics, and even the platform electronics. Look at this left side, you see a platform with a signage system, which is also in a surrounding, which I wouldn't call it a living room ambient. They are also in rain, in frozen area, in sunshine, and so on. So also they have stronger demand on ruggedized electronics in the background. And if we now go take the bridge to the next slide and look, there are also other industries which have similar or very similar requirements like the railway. We have this picture there from this oil and gas platform, which is also in harsh environment. But if we look into other branches like construction machines, you see that symbol of the crane, you see the forklift. We are talking about buses and other transportation solutions. We are talking about this digging machines that are available in small, in big, in very big. And so all these industry fields are very much interested in this portfolio, which originally has been designed for the railway market. So what exactly are now these requirements that this harsh environment comes with? And let's say we can describe it with the topic of a generally greater disruptive force that the applications in this way have to tackle, more than a stationary application, for example, in the medical field, which has other requirements. So what are these greater disruptive forces? I have some examples here in that sheet. So if we are not talking about applications that are connected safely to a main socket, then we have, in most cases, a pretty unstable and very noisy power source, which is very wavy, so you have to have a very wide input voltage range. Isolation is always a question, also with regards to safety. Then we have shock and vibration demands to cover, not only on the rolling stock. I mean, also a track bed is vibrating if a train comes across. We are talking about fire and burning protection, not only for the passengers, also for maybe freight transportation. Very often EMV, EMC questions and conformity are coming up. And then we have a big portion which is called temperature. We are not only talking about the temperature range itself and the high and low end temperature, startup temperature, we are also talking about temperature shocks. And these temperature shocks are automatically coming with humidity and condensation topics that need to be tackled. And why is this so? Just a small example from my own experience. Imagine there is an intercity express traveling from Frankfurt to Milan. This connection really exists. So this train is driving for hours in the Rhine Valley through Germany in summer at 35 degrees outside temperature in the pure sunshine. And then it comes to Switzerland. And then it enters with 250 kilometers an hour, a tunnel through the Alps, where the tunnel temperature is not 35 degrees, but maybe rather 5 or 6. And so this temperature drop, you can easily call a temperature shock, and then automatically humidity is created, condensation happens, and so yeah, water and electronics, I don't need to tell you about. So now this is my view on the things, what we need for this kind of products. But also other people have, of course, thought about this. So there are norms outside that are describing this kind of challenges much more in detail. And one of the norms that is always taken very close is the EN 5155. So that's the, let's say, the basis standard for the railway electronics. It's defining the environment conditions, and it's defining the expectations that the railway applications have with regards to electronics. So it defines the safety, it defines how they expect a power supply, for example, has to be designed and what it has to come with. So they are talking about the DC input ranges, so they have defined which window you have to hit with your product when it comes to input voltage range. It's talking about the noise that is allowed. It's talking about humidity levels, and all these things you can find in this EN 5155. And if you have a product which is certified with this, then you can be sure that you are covering all these questions. Further norms that are very important are, for example, the EN 61373. Here it comes to very detailed description of the random and vibration requirements and the shock resistance, how the goods have to be tested, what forces they have to withstand to make sure that they are good enough for the industries. And some additional norms, very often the RIA 12 is taken as a reference. There are norms with regards to the EMC directive and EMC areas. We are talking about RF, we are talking about safety of passengers in the event of fire. So there are a lot of norms that can be taken as an example and for questions here. So now we know what we need to have in place to be good enough for this market. Now let's have a look how we are tackling this with our products. And so I start now with the features with regards to the input voltage range. So we have seen 2 slides before how the norm is defining the input voltage range. And we see here in this picture the bandwidth of voltages. So unfortunately, I think my mouse pointer is not shown on the screen. So I describe it a little bit more. So the norm defines 4-to-1 input range as a minimum standard for railway applications. 4-to-1 means that the top end of the input voltage range is 4 times the lower end of the input voltage range. And so this gives you a bandwidth that is covering a wider range than standard DC-DC converters usually do. For other application fields, that means that with a 4x1 input voltage range, you can cover more than one standard, let's say, nominal input voltage for standard applications. So, for example, if you look on this 4-to-1 input low version, it starts with 9 and it's going up to 36. So, with a converter in this input range, you can cover a typical 12-volt application input voltage range, and you can cover a 24-volt input voltage with one and the same converter. That gives you some freedom, and this gives you some opportunity to use the same converter design for different applications with different input voltage ranges. Sorry. So now the newer products that we have introduced, I will tell you later on if you go into the portfolio, they are coming with a 12-to-1 input voltage range. So the window has been expanded a lot. So if we look on this upper 12.1 input age graphics, you see it starts with 14 volt and can cover everything up to 160 volt DC. And that makes it pretty easy to fulfill all the waves that are coming with the power lines into your application. And also here, for other applications, you can cover with one of those converters more or less all possible and typical input voltage ranges you can have, starting here from 24, 36, 48, 72 is all included in that range, range window. Coming to the next, shock and vibration. On the left picture, you see our test unit that we have in our engineering center in Ireland. So this is a vibration generator, let's call it like this. I'm not sure if this is the right wording, but on this machine, we are simulating shocks and vibration. So you see it's a pretty massive thing because the level of vibration and the level of shocks we have to withstand are pretty high. And so we can simulate this very well and can test our own if our products are good enough to keep that, to tackle this. So now, if we are talking, for example, about board-mounted DC-DC converters, you see on the upper middle picture our TMR3 converter, which is a 3-watt converter with a single inline pins to be mounted on PCBs. And these little pins in a high vibration area, they are a little bit under risk to break in hard vibrations. And that's why our railway version of the TMR3 is coming with an additional supporting pin that is you see there in this red cycle. This supporting pin gives more stability, a lot of more stability, to withstand this shock and vibration and let the pins be more stable on the PCB. On the right lower picture, you see a small part of our TEQ300. So this is a power supply solution which is not mounted on a PCB. It would be a little bit too heavy for that, to be honest, because it feels like a brick, if you will see it later on if we talk about the portfolio. And this is connected by cables, and also cables are under risk to get loose under vibration. So while standard power supplies often come with screw terminals, this here is coming with the spring clamps that are much more massive and much more reliable if it comes to vibration and shock, and holds the cables much better than a screw terminal could ever do. So these are some examples how we are tackling the shock and vibration features that are needed. Then we talk about temperature and humidity. We spoke about the condensation. This is easily done if we just make sure that the water can't come into the electronics. So we are talking about conformal coating. We are talking about gold plating to make sure that these things are covered. And for the heat, many of our products are coming already with an integrated heatsink, or we could rather say the converter is integrated in a heatsink casing. And in this way, we make sure that the passive cooling is working and can be, you don't need to have any active cooling on top just for the power supply. So we have also this kind of plug and play solutions. I will show you later on a little bit more about this. And we spoke about the noisy and unstable input range. So you can get this under control with filter modules. And this is just showing our new TFI series. So we have now on as an accessory on our product portfolio filters, this TFI, which are made to work perfectly with our product range. And this is now the version where you can put the filters in your design your own. If you take a DC-DC converter, for example, in a PCB design, you can use this filter. But we also have solutions, and I will show you 2 slides later. We will show you more or less plug-and-play solutions where the filter is already included. And this now guides us to the product portfolio already. So what we call the Railway and Ruggedized portfolio is DC-DC converters starting from 3 watt in a 4:1 input range up to 12:1 input range, which are all certified with the related railway norms that I have described earlier. We have all an extended temperature range and are coming with the certifications and directives that you can see here. We have products in zip form factor, we have products in dual inline form factor in different sizes, and we have chassis mounting solutions, and we have this portfolio of the surge filters that I just mentioned before. And this means for you that you can find in our portfolio as well products that are mountable on PCB, and you find products which are chassis mounting, so off-board products. And this gives you the freedom to decide if you want to have something more or less plug and play. You see these heavy pieces on the left side with integrated heatsink. They are coming along with a filter inside already, and they are connectable by cables. So you can buy them and you can just put them somewhere in a cabinet, somewhere on the roof of a train, somewhere into the machine room of an engine. You can put them in, put the cable on, and you're ready. But sometimes you want to also design your own things, so you can also have the basic modules that are inside the off-board modules. You can buy them as a component, and you can make the design your own, and you can create a PCB, which is maybe covering also other application examples. Looking into a bit more details of the portfolio, and this is not complete, it's just giving you a look into that. So we're starting on low power range. We start with the TMR3 series, which is this single inline converter with the pin I've mentioned before. This converter is also available in 6 watts in the same form factor, and we are preparing now the next product range, which is the TEN3WRH. This is now a dual inline module in 3 watt and also available soon in 6 watt, which comes with a high isolation with 3 kilovolt AC reinforced isolation. And that's the main reason why this is a little bit bigger, because this electronics needs a little bit more space than the more or less standard railway 3 watt version in zip. From the 6 watts, we are then going into more or less long-term existing products like the 10.8 and 8 watt DIP24 metal package. We have 10 watts in a form factor 1 inch by 1 inch. This is a typical standard form factor with a typical industrial pin out that you can find in several components. We have in the same form factor the THN15, which is a 15 watt, and we have the pretty long known TEN20WIR, which is 20 watts, coming then in double size, so 2 inch by 1 inch metal package. And now we are reworking our portfolio. So we are introducing new products upcoming and partially available already. And you will see that we have a higher power density in the products that are upcoming now. So you see the TEN10 WIRH. This is again the high isolation version that you have seen already in 3 and in 6 watts. So this is the 10 watts brother, also under construction. We have a THN20, so 20 watts in a 1 by 1 inch package, which is pretty new. And I think it will replace this TEN20 WIR you see here on the right hand side, because this just has same power in half size. Same power we also put into a 30 watt WIR solution, which is under development and will come soon. We see a 40 watt 2 by 1 inch plastic case, not metal case, plastic case, which is also new, which comes with the high isolation, also new and under development. And we have on the left side the TEN60WIR. So to come back to power density, the module itself is in a 2x1 metal case, which you have seen at the 20 watt 1020 earlier. But now we put 60 watts into the same form factor. And you can imagine that this is creating a lot of heat. And this is why the 1060 comes automatically with an integrated heatsink. Or let's say, if we look a little bit on this, I call it the hedgehog design. If you look at that, then the converter is rather integrated in the heatsink. Then the heatsink is on top on the module. Doesn't matter. So it is cooling himself with passive cooling by having this hedgehog, this not the hedgehog on top, the heatsink on top. Then we go now up to the 75 watts section. There we see this rugged compact metal case. They are coming with a standard pinout as well, and they are coming as component, but you can ask for heat sinks integrated here as well. You can buy the heatsink as an additional product, as an accessory, or you can also mount it somewhere for conduction cooling. If you have a metal case that you can use as a heatsink, you can also mount it directly on that and use the conduction cooling here for this kind of products. In the same form factor, you will see we have also much higher power available. Now we go into the new ultrawide input range. I have spoken about this, so they are pretty new, and we have available the TEP40 series in a 2.3 inch by 1.45 inch form factor. Also, they can get accessories with heatsink and can be mounted somewhere on a metal plate. We have the same form factor for the TEP60 UIR. These two types are available right now, and you can buy them immediately. We are working on the market start for the 100 watt version, and we are also working on the future version for 150 and 200 watts in this 12:1 input range. Back to the more squared form factor, we find here the TEP100, we find the TEP200. So these are now the component versions that you can design your own on your PCB, but these modules are also included in the more on-off-board solutions. So you can use them your own, as I mentioned, or you can find similar products in the TEP and TEQ series, where you get the full solution, where the module is already mounted on a PCB, the filter is already integrated, and all is integrated into a heatsink, and is all connectable by cables with the spring clamps mentioned before. So these are a little bit more plug-and-play feeling than the components that you have to mount on a PCB. But the converter inside, in fact, is the same. So we are using the component portfolio to put it here into this plug-and-play versions. And we see we have 150 watts, we have 100 watts, we have 200 watts, and the high-end product is this little brick here. TEQ 300 WIR is at the moment the highest available power range that we are offering in that product range. Now this was, as mentioned, a short view into our product portfolio. It's not complete. We are showing our power supply portfolio, of course, on our web page. So I encourage you to come along from time to time here. You see news, you see NPIs, and also our web page tracopower.com is split into that market sector, so you can easily identify by clicking and filtering the Railway portfolio, and you can have a look on this information there. And also, of course, we have the specialists from Telerex that are available for you, that are trained on this on our portfolio, and you can ask questions there, and they know easily how to find me. So we are happy to support you with any kind of questions here. What we also have is a Railway catalog. This is this brochure you see there on the left side. This is downloadable on our webpage as well. You can have it as a PDF, but we also have the good old paper version available and can send this out as well. So this is how to find our portfolio on the web. And to be honest, I'm not sure where we are with regards to timing. I think we were a little bit quicker than planned, so we have more time for your questions. Let me quickly see. I opened the chat. What here came in. Let's see where we are. Okay, we have, when choosing the onboard converters and decide to make the design around the converter my own, are there any helping documents available, like application notes, that help me in the design process? This is the question. Yes. Yeah, thank you for this question. It's very helpful. We have on our webpage a lot of information available as a standard. So if you look for products, if you find the product that you are interested in, there are on the page, on the product information page, already available links to the data sheet that is giving you a lot of information. There are links to application notes that are describing the hints and tricks that you need to know if you are making the design your own. So they are talking about temperature curves, they are talking about maybe parallel connection, they are talking about curves and derating and all these things that are important for this. So you can find them on our webpage. If you don't find the information on your webpage, on our webpage, then it's worth to give us a call or to contact us by email through Telerex or directly. And you can get connected to our technical support. Our tech support is located in Switzerland, so there are real people, not bot systems or something like that, real people that are reading your message, that are diving into your application and can give you supporting documents or hints and so on. So this service is available as well for you. I hope that answers this question. Next question is, how do I identify Railway approved products in the Traco Power portfolio? Is there any hint in the documents, products nomenclature? Yes, also very good and interesting question. Thank you. Our nomenclature is pretty well visible. Let's step few slides back and take an example here. So we have this, for example, here this TEP, it's a little bit small, is the 150 or 100, just 100 WIR, so my screen is too small. So we have the TEP 100 WIR. All our products are starting with a T, like Traco, and then with a two letter code, which is defining the series. In this case, we have the TEP. Then we have a blank, and then there's a number code, which is defining the wattage and that this product is able to tackle. So in this case, we are talking about 100 watts. On the other side, TEP 200, we are talking about 200 watts. Then there comes a dash, and then is following a 4-digit number, which is defining input range and output voltages. And then there comes the suffix, which we see here, WIR. And this WI is standing for wide input, because we are talking about a 4-to-1 input range here. It's a wide input. And then R is for Railway. So this WIR gives you the hint that this R here is definitely a Railway product. The TEP200 WIR is a Railway product. And if we come back to the UIRs, you see it's a UIR, Ultrawide Input, Railway. And then we have this new products, 1040 WIRH. It's 40 watt, wide input range, Railway, H like high isolation. So you can, if you play a little bit around, you can try to identify these things. You don't need this to know this on your own. It's just a hint that the nomenclature gives you if we are working in the Railway area. It's also not 100% valid. Some older products don't have this R yet, but are still certified for Railway. Also here, I encourage you, have a look on the web page, go to the Railway application area, or talk to your contact persons on Telerex. They can easily find out and support you and give you the safety and security that we are talking about the right things. All right, that's for now all questions I can see here in the public chat. So I hope there are further questions. Sorry. Okay, thank you, Quincy. There are no further questions anymore. Yeah, in this case, I'm on the end of my documentation. I hope that this presentation and this little outlook to future products and dive into the existing products was interesting for you, was helpful for you. As mentioned, we are there. And I can only say thank you to everybody. Thank you for joining, for taking the time being with us here this morning for the webinar. Thanks again to the Telerex team for the invitation and the chance to be a presenter here today. And yeah, then I would say I close that webinar here from my side and give the word back to the team of Telerex.